Stanford University.
Okay, hello everybody, and welcome back to lecture number 6, I think. I'm going to start off today's lecture with finishing up the demo from last Thursday. I'm going to review quickly what we did for last Tuesday. We're going to review quickly what we did just so you can remind yourself, oh, yeah, that's what we were in the middle of doing. Specifically, we created this custom UI view called Face View, you'll remember. And we actually added the delegate in its header file, this mechanism where it can delegate its data. But actually, I'm going to go back and show you how we're going to use the delegate in Face View again, because I kind of rushed through that, and I want to make sure you understand that. Then today in that demo, we're going to, we already modified our header file and our controller, so we're going to actually go implement our controller, including our nice int model. And we will be adding outlets and just generally implementing our controller. When I'm doing this today, you want to watch for using the proper property syntax to do memory management on IB outlets. This is the first time I'm going to be doing this in a demo, but this is the way you should be doing it going forward. We're going to watch for how we update our model. I'm going to update the model using a property setter, and I'm going to be careful to protect the integrity of our model, not let it get set to something bad. And I'm also going to keep our UI in sync when our model is changed. Okay, I'm going to actually publicly allow our controller to change the model. I'm going to have a public property in our controller that allows the model to be changed, but I'm going to make sure it doesn't break it. You could argue that the model needs to protect too, but since the model is an int, it can't do that, so I'm going to have the controller do it. Then we're going to see how to use that custom views delegate property. Okay, we defined it in Face View. Now I'm going to show how the controller actually implements that delegate and how we use that to make our UI work. So that's what we're going to do. So I'm just going to go back into Xcode here, where we left off, which was happiness. Let me hide others here. Okay, so little quick review. So here is Face View. All right, this is our custom view. You can see this was our designated initializer overriding. We didn't actually do anything in our overriding of that. We created this little utility method that draws a circle. You can see at the beginning it pushes the current graphics context that it's being asked to draw in. Then it does what it needs to do, and then it pops it off. That way, if it set a line width or a color in there, it wouldn't affect the person calling it. Then I actually just find the middle and size of my view by using self.bounds, right? Then I get the current graphics context using this UI graphics get current context method. And I call that draw circle at point that I defined up there to draw the outer rim of my face, okay? Then I had a little code that I copied and pasted in actually that did the eye. Here's the eye code, the two eyes. And you can see the code is very simple. It just goes to the middle, moves over a little bit, up a little bit, calls that draw circle, moves over, calls draw circle again. Okay, so that's the eyes, super simple implementation. And then here's the mouth. The mouth is a little more complicated because we're doing it with a Bezier curve. Remember, start point, end point, and then two control points where we create tangents between those lines, and then we draw an arc in between. If you don't know anything about graphics, there's Crash Course right there. We set up all the mouth start and end and control points in here. And then we move the control points down depending on how much we're smiling. Okay? That's this smile offset right here. Now, let's go right into how we're going to use our delegate. So remember that our delegate, if we go look at the header file, it delegates this method here, smile for face view. And that's going to send a message to our face views delegate saying, tell me how much I'm smiling. From -1, a full frown, to 1.0, a full smile. Okay, that's what it documents as its interface. All right, so now in our implementation, we're going to call that method to set our smile offset appropriately. But what I'm going to do here is, to be a little safer than I was before, is I'm going to get my smile from my delegate. And self.delegate is the property. If you'll remember, we added a property here. Okay, it's an assigned property. It's an ID that responds to the FaceView delegate protocol. It's called delegate, and that's what our instance variable is right there. All right, so we're going to send a message to that instance variable, to that property, saying get the smile for face view self. Notice that we pass our self when we ask our delegate, just in case our delegate might have some questions for us. That's kind of just the convention that we do. And I'm actually going to make sure if smile is less than minus 1.0, then I'm going to make smile equal to minus 1.0 so that it can't be too small. And same thing, if smile is greater than 1.0, then I'm going to set smile equal to 1.0. Okay, that way I'm just bounds checking. And this is something you probably want to do from your delegate. If your delegate is going to give you some information, you might want to make sure that it's not giving you bad information, because you might have a bad delegate. And so then I can just times smile here to make my thing smile. Now if I run this at this point, we're going to not be smiling. And that's because our delegate is nil. And so that method, that delegate method that we saw here, is returning 0. And remember that 0 means not a smile or a frown. So that's why we're getting 0 here. Does everyone understand what's going on there? Now, before we go over to our controller and actually implement this delegate so that it's returning an actual smiliness, I'm going to show you a little bit how we could change the color of our face and the line width. All right? So I'm actually going to do this at the top here because I want the circles to be changed as well as the mouth. So I'm going to set these attributes, these drawing attributes, graphic state, before I do any of that drawing. And so how do we do line width, for example? Well, we do context, set, line width, and we provide the context we're drawing with, and the width of the line. I'm going to say 5.0. And this is in points, the same kind of points we were talking about before. The same points that's in the same space as the font, the points of a font, things like that. And then how do I set the color? I just go UI color. I'm going to do blue. Okay, so blue color is a class method in UI color that returns an auto-released blue UI color. And I'm just going to say set stroke. Okay, which remember there's fill, which is the color to fill the thing, and stroke, which is the thing to draw the lines with. So if I do that, just that, and rerun, you'll see that my face is now blue and has thick line. Okay, and there's plenty of other things you can set. I just wanted to show you those simple ones. So we've got our face view done. Now we're going to go and implement our controller. All right, so let's go back to our controller. Here's our controller's header file. Remember that here's our model. Okay, here's our two outlets. One is to a slider, and one is to a face view. I haven't put the slider in there yet, and I haven't wired up the face view yet, but I have the outlets. Here's this new syntax I was talking about that we're going to do our memory management with. You see I've created @ properties for my outlets. And I've made them retained, and I put IB outlet in there. In fact, I didn't put IB outlet on my instance variables anymore, you notice. You can put them in both places if you want. Interface Builder won't get confused. All right? But we always put it in our property. That's usually the place. You can put it in both or just in your property. And then I have one action here, happiness change, which is the slider is going to send to me to change my happiness, cause me to get happy or sad. Now, I'm going to add one other property to my controller, which might seem a little strange, but it's actually perfectly reasonable, which is happiness. Okay, I'm basically exporting the ability to set my model's value. Right? Happiness is an instance variable, it's my model, and I'm having a property, it's a public property. I'm declaring it in my header file. I'm allowing the value to be set. But I'm going to be kind of careful in how I allow it to be set because I don't want to let someone set it to something that's really going to be bad and break my model. Because my model only works from 0 to 100. If you set my happiness to 200, you've kind of broken the model. So we're going to protect our model from getting broken there. All right, and we'll see that in a second. So let's go to our controller. It's got a lot of extra code in here helping us out. There's a view did load and things like that. So we're going to get rid of most of this because we're not going to do any implementation. We're just going to do supers. But I'm going to start by synthesizing my properties. So I'm going to say @ synthesize. And I'm actually going to synthesize my two outlets on the same line. I'm going to say face view and slider. Those are my two outlets. And I'm going to do a different synthesize for my happiness. Happiness. Okay? Now, synthesize, you can put as many on there as you want. I like to kind of group them based on what they are, outlets or the model, whatever. And also I have to do my memory management here. Okay? So I'm going to create a nice little shared method called release outlets. I showed you this in the slides. And in there, I'm going to say self.faceView equals nil, and I'm going to say self.slider equals nil. Okay? And that's going to release my outlets because they're retained. So when I set them to nil, it's going to release the old version and set the value to nil, which will actually be a nice thing too. And then in view did unload, I'm going to just call self-release outlets. Okay, and I'm going to do the same thing here in dealloc. Okay, if I type that wrong or something, not helping me there. Okay, so there I've done my memory management for my outlets. Okay, that's all there is to it. You're going to want to do that whenever you have outlets in the future. Now, next I'm going to do my action method, IB action, change happiness. This is sent to me from, change happiness. It's sent to me from a slider, sender. And all I'm going to do in this is I'm just going to say self.happiness equals the sender's value. Okay? So value is a property on a slider, returns the value. It actually returns it as a float, but Objective-C will automatically cast it to an int here. But I said I was going to protect my model, and that's not very much protection. But this is not really where you want to put the protection. You want to put the protection anytime someone sets your model's value. So I'm going to do that in the setter for my property. Okay? So this is the setter. I already synthesized this, but I'm going to provide my own version, and it's going to count, and the synthesized one is not. So I'm just going to say here, if the new happiness is less than 0, then the new happiness is 0. Similar kind of thing I was doing in the face view, just protecting here against bad values. And if the new happiness is greater than 100, then the new happiness equals 100. Okay, so I'm just going to make sure that's good. Now I can set my happiness to the new happiness because it's been bounded. And then the next thing I'm going to do whenever my model changes is I'm going to update my UI. Okay, so I'm going to call this method update UI, which I'll have to implement. So let's do that. And update UI, what UI do I have? I have my face view and I have my slider. So I'm going to update both of those. So the slider is easy. I just say self.slider.value equals self.happiness. Okay, boom, my slider is now up to date. Every time my happiness changes, my slider is going to get changed. That's good. Now, how about my face view? Remember that the face view delegates its data. It delegates its smiliness away to me. So all I need to say here is self.faceView set needs display. Remember I talked about that in the lecture. That's just a message to the face view saying you need to redraw yourself, okay, because something you depend on, namely the delegate, has changed. Okay, and so that's all we need to do to update our UI. Now, the next piece here is to implement that delegate, FaceView's delegate in my controller. All right, when I told you every time you implement a protocol, you have to declare in your header file that you implement it. So I'm going over to Happiness View Controller's header file. This is my view controller. And I'm going to say, I implement the FaceView delegate protocol. Okay? And I'm already importing faceview.h, which is where that delegate protocol was defined, right here. Okay? So now I've proclaimed that I'm going to implement it, so I better darn well implement it. And in fact, if I compile, I'll get one of my warnings down here is going to be that Happiness Controller does not fully implement the FaceView delegate protocol because I haven't implemented any of it yet. All right? So let's go do that. You can do that right here. You remember that this protocol is smile for FaceView requester. I'm actually going to make sure that the person sending me this is my own FaceView. So I'm going to say if requester equals self.faceView, then I'm going to answer this. Otherwise, I'm not even going to respond. I'm going to do a local here. I'm going to say float smile equals 0. So I'm going to return 0 if this is somebody else. And then I'm going to say smile equals. Now, I have to convert my happiness into the smiliness. And this is an important thing that controllers do. They interpret data between the model and the view. So I'm going to do that here. And it turns out this would be float self.happiness minus 50 divided by 50. Okay, that makes it so that 100 is 1.0 and 0 is -1. Okay? And then I'm going to return the smile. Okay? So, not quite done here. We've implemented the delegate. We've got everything working when the happiness changes. So one other thing we need to do, which is when our view is loaded out of the interface builder file, we need to do a couple things. Okay? So that's view did load, remember? And in view did load, I'm going to do two things. One, well, first I'm going to call super view did load, which is something you always need to do on these view dids, except for view did unload. Seems to be the only one that doesn't require it. But all the view dids, you want to call super and let super have a chance to load whatever they want to do. And then I'm going to do two things. One, I'm going to set the face views delegate to myself, right? Because I need to do that. It's not going to work for me to implement that delegate method unless I'm the delegate, so I'm going to set my face views delegate to myself. And then I'm also going to update my UI here. Make sure my slider matches up against my happiness. Okay? All right, so that should be all we need. Fix any syntax errors or other stuff that we have, which we don't have any. Oh, one more thing we need to do. Let's put our slider in. Forgot to do that, so let's go to Interface Builder. Oops, sorry, quit the wrong app there. Happiness. Let's go to our Interface Builder right here and put a slider in there. So if you go look in the library, it's right here, slider. I'm just going to put it right here, like that. And then I'm going to wire up, using control, like you're used to, my face view, and I'm going to wire up my slider. And I'm also going to go the other way from my slider to happiness changed. Okay? Everyone understand what I did there? Real simple. It's the same thing we always do. And now I'm going to run. And now, hopefully, I'll have a slider in my UI. There it is. I'm pretty sad because my happiness started out as 0. Remember, all our instance variables got started out as 0, so our model started out as 0 as well. But if I crashed. That's not good. So where are we going here? Probably in here. Sorry about that. All right. Well, let's go see what happened. A little on-the-fly debugging here. It says happiness changed is unrecognized selector. So here, that's why. Happiness changed. Okay. Your console, by the way, great place to debug. You don't always need to be in the debugger and having breakpoints. You can look in the console and it'll tell you when an object doesn't understand a method. Okay. So that was an easy one for us to debug. Here it is. Let's try again. Still no good. Oh, okay. Another problem. I understand real quick. Our slider, let's see what values it can have. It can go from 0 to 1. Well, that's not very good. Let's go from 0 to 100. How about that? That looks better. All right. Now we have happiness. Okay. Now the instructor is happy as well as the face view. All right. So that's it for happiness view. Everybody understand all the pieces of that, hopefully. We're going to use this MVC in our next demo at the end of class that is going to have actually two controllers, two MVCs linked together. So you're going to see this again soon. All right, so let's hit the slides here. Yep, next slide. Okay, so what are we going to do today? We are going to go under the hood of view-based application, right? You go into Xcode, you say new project, you say view-based application. We're going to go under the hood of what that actually does, what files it creates, etc. We are also going to talk about the application lifecycle. Okay, an application starts up, what happens as it runs, and then when it finishes. We're going to talk about the view controller's lifecycle, from the time you alloc init one all the way to the time it's dealloced. And you've never seen one get dealloced before, but you're going to today, right? Because we're going to have a controller that is a subcontroller of another thing. It's going to create one, be on screen for a while. It's going to go off screen and be dealloced, okay, released and dealloced. So we're going to see what happens all in between, what methods are called, things like that. Then we're going to talk about controllers of controllers. Specifically, we're going to go into UI navigation controller, a very common controller of controllers. And then I'm going to do this demo at the end where we're going to look at happiness appdelegate.m, which I'm sure you've been seeing it there as you do all your programming, saying, what is that appdelegate.m thing? Well, we're going to look in there and see what it is. And we're going to create a new window-based application instead of view-based application. And then we're going to implement a UI navigation controller. All right. So when you go into Xcode and you say, new project, view-based application, what files is it creating for you? Because it's basically just a template it's copying in, okay, and renaming some things. So it's creating basically these files. It creates a couple other ones, but these are the main ones to worry about. Main.m, the happiness view controller, m&h, and .zib. This thing called mainwindow.zib, which is a nib file we haven't looked at. And then happinessinfo.plist and a happiness app delegate, which we're going to look at today. So what are these files? Main.m, really simple. It's just that standard C entry point of int main, int argc, char star argv, right? That's just all C programs. That's their entry point. Unix C programs enter there. If you go look at that file, which you're welcome to do, you'll see it really just creates this auto-release pool thing, which I'm going to talk about in a few slides. And then it calls this function UI application main, which starts up your whole application. All right? Happiness view controller.m&h and .zib. Hopefully by now you know what that is, right? That's your controller. The view-based application template in Xcode creates a controller. The window-based application template does not. Okay, and we're going to be doing the second one today. Mainwindow.zib. So this is kind of an odd little nib file. It contains a UI window. Remember I told you in an iPhone app or an iPad app, there's usually only one UI window. It's the very top level of the view hierarchy. Well, that UI window is created in this mainwindow.zib, right? Because in your happiness view controller.zib, there's no window in there. It's just, it starts with a view, the view of your view controller. So the UI window is created here. It also has an object in it, which is called your application delegate, which is a subclass of NSObject, and it happens to implement UI applications, UI application delegate protocol. And we'll talk about what's in that protocol in the next few slides as well. So that's what mainwindow.zib is. Mainwindow.zib might be different on different platforms because the UI window is a lot bigger on an iPad than it is on an iPhone. And you can build applications where you have multiple mainwindows.zibs, and the one app will run on multiple platforms, and we're going to talk about that next week. Okay, it's going to be part of your homework after this current one. And then there's happinessinfo.plist. There's a lot of important stuff in there. I'm going to try and cover that as the quarter goes along instead of trying to go through it all at the beginning, because some of the things won't really make sense until you understand what's going on inside UIKit. But it's basically a bunch of, it's a property list. It's a bunch of settings for your application. Sets how it starts up and what orientations it supports, all that kind of stuff. Now, happiness app delegate.m&h, this is a new one for us. It does a few things with view-based application. One, it has two instance variables. One points to that UI window in mainwindow.zib, and another one points to your view controller, happiness view controller. Right? So it creates an instance of your view controller and has a instance variable that points to it. It has a lot of stubs in there for application will do this, application did do that, okay, which is typical delegate talk, right? And we're going to look at a list of those. The most important one of those is application did finish launching with options. Okay, this is the method you're going to override to build the start of your user interface. Right now, in a view-based application, what it's doing is it's just taking your view controller's view and filling the whole window. Okay, that's how your view controller's view is getting on screen with one line of code in happinessappdelegate.m. And we're going to look at that briefly today when we get to the demo part. This is also where the UI window is made visible. There's this line of code in there, window make key invisible, that makes it appear, actually start drawing on screen. All right, so we're going to modify this method today to create a controller of controllers to build a more complicated user interface. All right, so quickly, here's what the happiness appdelegate.h header file looks like. You can see it's got two outlets. That's all it has, these two IB outlets. It's using the proper @sign property notation, you'll notice. It implements UI application delegate protocol, which is all those app will do this, app did do that. Here's the IB outlet for our window, and here's the IB outlet for the happiness view controller that view-based application template creates for us. Window-based application does not create this particular one. So application did finish launching. This is the method that's called when the UI kit is completely gotten everything ready to go, and it wants you to go. So this is basically, it's finished launching, it's finished getting going, now it's your turn to make something happen. So what happens here in the happiness view controller case, the view-based app, is it only has two lines of code. One adds our view controller's view as a sub-view of the window, right? Filling, and its frame is already set to fill the whole window. And then it does make key invisible, right? And it turns yes that we're ready to go. Notice that view controller right there, that's the instance variable that is set up in main window.zib to point to your view controller. That's how your view controller gets instantiated. That's how it exists. And then .view is the property on a view controller that is the top level view of your view controller's view. All right, and we just call add subview, which we talked about last time on the window, to get that thing added to the view hierarchy. So after application did finish launching with options gets called, and you set all that up, and you make the window visible, then what happens? Okay, then the application goes into what's called a run loop, where it's just going around and around doing the same thing over and over, which is creates this auto-release pool, which we're going to talk about, waits for events, and these might be touch events, they might be some timed events you can set up, they might be I/O events happening, network or whatever. These events are then dispatched through UIKit objects, might get to you through delegates and other mechanisms. And then when all that's done, the screen gets updated where necessary. So draw recs get called for things that got uncovered or things that came on screen or things that changed their position or, they got stretched or something like that. But draw rec is not called unless something changed or someone said set needs display. Okay, if nothing changed about the size of your view or position or uncovering, then the only way your view gets drawn at the end of this loop is set needs display. That's why we called set needs display in our happiness view controller. Okay, so then this happens over and over. So I have a graphical view of this so we can understand this auto release thing because I know a lot of you have asked about that. So here is time moving along the bottom. Our app gets launched, it gets initialized, it calls did finish launching after the main nib file is loaded, and then we get to this point here where it's waiting for event. At that point, a pool, NS auto release pool is the name of the class, is created. Okay, it's just an object that's instantiated. And then as you go around the run loop, running, okay, objects that are sent auto release get thrown into this pool. So here's an object, object 1, right? It got auto released, woo, it just went in the pool. Okay? It didn't get released, it just got thrown in the pool. And then here's another one, object number 2. Auto-released, wham, goes in the pool. Okay, we're running around the loop. Here comes object 1 again. It got auto-released again. Okay, so it got auto-released twice. Okay, now we've come back down to the end of our loop, and we're going to drain this pool. And when we drain this pool, here's what's going to happen. Object 1 is going to get set release twice, and object 2 is going to get sent release. Okay, notice this is all happening after everything's happening. We're just about to go back in and wait for another event. All right, so all our drawing has happened, et cetera. All our stacks have unwound. All our delegates have been called, et cetera. And when we do this, those objects will get released. And if they're the last owners, they'll get deallocated. And sometimes if this happens and you still have a pointer to one of these objects, that's when you get this strange, difficult to debug state where you get bad access. And it doesn't even seem to be in any of your code. It's like, I didn't release anything. Well, it's because you probably released something that then later got auto-released, and then you're going to have bad access. Okay? Happening deep in the bowels of this loop. All right? So the best way to debug release problems like that, we get the bad access, is to take your releases and auto-release calls out of your code, comment them out, and then put them back in and see which one is causing the crash. Until you really understand when things are getting released and retained and all that. Once that's become second nature, you won't have to be doing that. But that's a good way to do it early on, the first few weeks of this class. All right, so window-based application in Xcode as opposed to view-based application. So here it's pretty much the same, except for notice we have no instance variable for a view controller. It does not create happiness view controller.m and h and zib. Okay, that's up to you to create. All right, and you can see right there in the did finish launching, it only makes the window visible, which is just going to be blank because there's no view added to the subview there. Okay, before we talk about that more in detail, I want to just give a brief look. I'm not even going to go into these, but this is all the application delegate methods, like did do this, did do that. You can see you get notified when you resign being the active app and enter the background. When you come back into the foreground, this is the whole multitasking thing in iOS 4, where your application doesn't quit anymore. It essentially just goes into this background state. Right? And you have a little bit of time to do something when you first move in there, and then you're kind of be inactive, but then you'll get reactivated at some point when the user clicks on you again. All right. You'll also get notified at the end there when you're going to terminate. The user is quitting your application. They probably clicked the main button on their iPhone 4 and they're going to some other application. Nowadays, with the multitasking, you don't get that message quite as much because you get moved to background. But your application can still be killed, even in multitasking world, if you use a lot of memory. Okay? When the iPhone runs out of memory for all its apps, it starts going looking for apps to kill. And if you're using a lot of memory, you're going to be high on its list. Okay? So that's why we want to manage our memory well and not leak, because when we're going to be using all this memory or have all these big images or sounds that we're not really displaying right now, we're going to put ourselves on the top of the to be killed list. You can see there's other things, receiving notifications. We'll talk about a lot of these later in the course. All right. So that's application. That's the application lifecycle. Now let's talk about view controller and how view controller works, okay? Basic view controller, you should have a good handle on right now because you have implemented your own view controller, and it's the fundamental piece of this MVC. So you already know that. There's a very important property in UI view controller, which you've seen already in these slides, and you've probably seen it in the interface builder when you wire things up. It's called view. Okay, this is a property on UI view controller. View is the top level of the view controller's view, right? It's the biggest rectangle that's containing all the stuff in your view's view. The view controller, just like the application, they kind of have a life cycle from creation to deallocation. And it starts with alloc. The designated initializer for UI view controller is this thing called init with nibname bundle. I think I might have mistakenly said it was init last time. 99% of the time you're calling init to create your UI view controller, but this is the actual designated initializer. The UI view controller tries to get its view from this zip file specified in this thing. If nibname is nil, if you call this with nibname of nil, it tries to use the name of the class as the name of the zip file. That's how you're getting happiness view controller, right? Because the name of that class is happiness view controller, so it's looking for happiness view controller.zib because this is being called with nil. All right? The bundle thing allows you to specify different zip files for the same view controller, mostly based on localization. So you might have a German zip file and a Swedish zip file and an English zip file and a Japanese zip file in these different bundles, and it'll look in the bundles. And we're not going to talk about bundles right now. We're going to talk about localization towards the end of the quarter. We'll talk about it. But if you pass nil for a bundle here, you'll get basically the resources folder in Xcode. You know, the resources folder on the left where your zip file is and things like that. That's where it's going to generally look, approximately. Initializing UI view controllers with init, which is now a convenience method because the designated initializer is init with nibname. But that's very common. In fact, 99% of the time you're going to use init. And init just calls this method with the nibname and the bundle both set to nil. So it's going to basically get a zip file with your class name in the main bundle. All right. What if you don't want to build your UI view controller's view with a zip file? Is that allowed? Do you have to use a nib file to build your UI controller's view? The answer is no. And in fact, in homework number 3, or maybe it's homework number 4, you're actually going to be doing this, building a view controller that has a view, but that view is not comes from a zip file. The way you do that is with this special method right here, void load view. Okay, if your init with nibname bundle tries to go out and find the zip file and it can't find one, then it calls load view. And load view is responsible for setting that view property. Okay, the view property in UI view controller, very important to be set. So this load view is responsible for setting it. You would never implement both load view and have a zip file. That would not make sense. Okay, in other words, you wouldn't want both of those pieces of code running, right? Because they'd be trying to do the same thing, kind of colliding on each other. So after the view controller is initialized, view did load is called. And we already saw that in the demo we did. It's a really good place to put setup code, really good. But be careful because the geometry of your view, where it is on screen, how big it is not set in view did load. All that's happened in view did load is you got loaded out of interface builder. You're going to be whatever size you were in interface builder. If you then get scrunched into a smaller space and resized, That's going to happen later. All right? So you really can't do any initialization based on your size if you're going to have a flexible sizing view in view did load because it's not set yet. But there is a method for that, which is view will appear. Okay? So view will appear gets sent to you, to your view controller, when your view is just about to be put on screen. And at this point, all your bounds and everything are set. So now you can make some calculations based on what size am I want to initialize something or whatever based on my size. This is where you do it, view will appear. But remember that view will appear might be called a lot because you'll come on screen, then someone clicks the back button, you just went off screen. Someone clicks another button, you're back on screen. So view will appear will get called again. So view will appear gets called a lot. So don't be doing something that really wants to be done in view did load only once in view will appear. Some people kind of get lazy and they say, I'm just going to put everything in view will appear because I know in view will appear that my bounds is right and I can just do whatever I want. Think about which goes where. Okay, some things go in view will appear. Most things go in view did load when it comes to setup. Then there's also view will disappear. This gets sent to you just before your view goes off screen. All right. You might ask, what would I do here? You might save some user setting like where they're scrolled to so that when they come back, you can, the next day, you can come back to that same spot, things like that. If you're going to do something expensive like save data to permanent store might do right here, like save some big database entry or whatever, you might want to think about doing it in a thread. And we're going to talk all about how to do expensive operations in threads so that the main thread never gets blocked. Okay? There's also the did versions of both of those. View did appear and view did disappear. Now notice that all these appears and disappears have this thing animated. You see that argument animated on all of them? That's telling you whether you're going to appear by sliding in or flipping up or something like that, or whether you're just going to appear. All right? And the reason you might want to know that is in an animated case, you might want to show something a little different on your view, or you might want to get involved in the animation, which we'll show you a little bit how to do later in the quarter too. Because on the iPhone, animating your user interface, things sliding in, dissolving, becoming opaque, and so it's very important for the user experience. And it's really, really easy to do. So we're going to be talking a lot about that. So you'll see this animated argument on a lot of methods, trying to tell you what's going on animation-wise. You already know about view did unload. It's where you get rid of your memory for your outlets. You could do other things there. I'm not sure what you would do if you had some data structures that had to do with your view. The view is getting unloaded, so this is where you would clean that up. Another important delegate method here, it's a should one, called should auto rotate to interface orientation. This is when I take my iPhone, okay, it's like this, and I rotate it. Okay? So here I'm going to be asked for the view that's on screen here, the view controller is going to be asked, should I redraw myself in this new orientation? Or basically, should I just tip over, be sideways? The default is only to support portrait, like this, up, right side up. So even if you turn it upside down, your view will be upside down, okay? So if you want to support upside down, where you want your view to draw around the other way, so that it still looks right side up, or landscape, where your view is now going to be wider than it is tall, you need to return from this method yes for whichever ones of those you're going to support. And there's these constants, UI interface orientation portrait, portrait upside down, landscape left, landscape right. You have to check if you're being asked to go to any orientation you want to support and return yes if you are willing to support that orientation. Then you have to actually work when that happens. Like, you got to draw yourself right if you're wider than you are tall. Okay? So we'll talk about that. When the rotation actually happens, you'll get these messages. Will rotate to orientation, did rotate to orientation. You actually don't do much in these methods. If you're doing something really expensive, you probably want to stop when the will comes, because you don't want to be doing some expensive operation while it's rotating your view around, because that might be animated and you want it to be smooth. But mostly the responding to rotation, you do that in your view. Okay? Your view needs to understand how to lay itself out if it's wider than it is tall, or taller than it is wide. Okay? And Interface Builder has a mechanism for going in and basically setting the stretchiness and the stickiness to the sides of your view, of the super view, of all your views. And by doing that, you can make it so that when you rotate, these two buttons stick to the edges. They spread out. The view on the top here gets wider to fill the space of the wider view. Okay, but it doesn't get taller. In fact, it might shrink down because you went from a tall view to a short. So all that's doable in Interface Builder. You do that in the inspector. Okay, one of the inspectors is the one that looks like a little ruler. If you go in there and it's graphical, you click on it and you can set the springs and struts that your view is, its stretchiness and stickiness compared to its super view, and it'll actually even animate it in there and show you this is what's going to happen as this view gets resized. So that's how you deal with rotations. Sometimes it's pretty easy to do that. Sometimes it's very, very hard. Okay, in your assignment this week, you're going to do a graphing version of your calculator. It's going to have two screens. One is the screen you have now with your calculator. Another one is a graph with just a couple buttons. Real easy to make that graph one work when you rotate. Quite a different thing to make the one with all those buttons. You almost have to relay out the positions of the buttons, okay? For example, on your iPhone, check out the app Calculator that comes from Apple, and you'll see what it does when you rotate. It actually puts more buttons in. You get more features when you do that. Okay, so that's something to check out. That's extra credit. Don't worry, you don't have to do this on this assignment. But it might be something you want to do with the graph view and not with the other one. I even say that in the homework. All right, special consideration for controllers that manage a collection of other MVCs. These are kind of weird controllers because you're used to MVC where the controller is just controlling this little rectangular view, and that's pretty much in all the things in it, and that's it. Well, here you're going to have a new situation where you got a controller, and when it displays something, it might be using whole other MVCs. Okay? It might be, in general, in fact, it is always, these controllers of controllers, their view is to have a whole other MVC construct draw for it. Now, this might seem like, what? How is that going to be possible? We're going to do a demo today. I'm going to write the code. You're going to see how it works. It's very straightforward. It makes a lot of sense once you kind of see it happen. There's a few of these in the UI kit. I'm going to mention three. UI navigation controller. We're going to go into great detail about that one. There's UI tab bar controller. You've seen that. That's tabs at the bottom, right? You click on the tabs and it's switching different views. Well, each one of those views is controlled by a different view controller. Each one of those views is a different MVC, okay, with its own view appearing. And then you probably haven't seen this unless you have an iPad. The split view controller. It's a master detail controller where when you're in landscape mode, on the left you have a view controller MVC system, and on the right you have an MVC system, and the one on the right is a slave of the master. So you click things in the master, the slave changes. And then when you rotate to portrait, it actually puts it in a little popover button. It's pretty cool. So we'll talk about all that next week because your next assignment is going to be to use split views. All right, so navigation controller, how's it work? You create it with alloc init, all right? It doesn't have a nib file associated with it because, again, it's going to use other controllers as its view. After you create it, you need to put the navigation controller's view, meaning its view property. The UI navigation controller is itself a UI view controller. Understand that, okay? UI navigation controller is a UI view controller. So it has a view property, okay? You're going to put its view on screen. Now, we do that the same way we do any UI view controller. We call add subview, right? Put it on screen. Usually we call it on the window in application did finish launching with options. But it's possible we might actually put the UI navigation controller's view in some other controller, like a split view. So you can probably even imagine having a split view where the left side is a navigation controller where you're navigating, and on the right side is some big view that, depending on where you're navigated to, is showing you some detail, right? So now you can see how you could have a controller of controllers inside a controller of controllers, right? A navigation controller inside a split view. So the code for this is super simple. There's really, a couple lines of code to make these things appear and disappear as long as your MVCs are well built, right? As long as your MVCs are built properly in terms of obeying the model view controller rules we talked about in the very first lecture, then it's really easy. So here's an application did finish launching. It creates a navigation controller there. See, my nav controller equals UI navigation controller alloc init. It adds that nav controller's .view to the window, and then it make key invisible and return yes. Now I see on the left there, I say something missing here. Okay, what's missing is this navigation controller is empty. We need to give it at least one controller to control. So we're missing that. but we'll get to that in a second. So this is what UI Navigation Controller looks like on screen. You've seen it a million times. It's the most common controller of controllers. I'm going to kind of show you the parts of this piece by piece. This little kind of red rectangular area in the middle, that is the UI view that's obtained from the view property of the UI view controller, which is on top of like a stack of cards. The navigation controller is basically managing a stack of cards, and you can put things on top of the stack and take them off. Put something new on, take it off. Take another thing off, take another thing off. Put 3 on, back and forth as the user navigates through some hierarchical data, tables, whatever. So for example, in our demo today, we're going to have a psychologist app. And the first page of the first card that's going to be on there is the psychologist asking how you are doing. And then based on how you answer, it's going to give you a diagnosis, which is going to be the smiley face. Okay, and that's going to slide on. Make sense? So that's what we're going to do today. And your homework is you're going to have the first page is your calculator that you know today and love, I'm sure, clicking on it. And then you're going to have a new button that when you press it, slides in a new card on top, which is a graph of the expression. Okay, that's basically your entire homework. So this center space is the view property, the UI view that's gotten from the view property of the UI view controller that's on top of the stack. Up there in the middle, you see that Gmail. That's a string that comes from the title property of the UI view controller that's on top of the stack. Okay, so it's always going to give you the title of that one. We haven't implemented the title property. You can just set the title property on a view controller if you want. The bottom there, those buttons like the little arrow and the compose button and things, that's filled out using an NS array of UI bar button items that is a property on the UI view controller on top of the stack. So you're starting to get the flavor of this here. The UI navigation controller is asking the top one on the stack for lots of information so that it can display its UI around it, whether it's the buttons at the bottom of the title, etc. And lastly, upper left corner, you see that button there that says accounts. That string is the title of the card next down on the stack that's not visible. And the reason that's there is if you click that button, it's going to take the top card off and show that card. So it's kind of like a back button, right? You've got stacks building up. You put something new on top. That upper left corner is going to button you can press to take that one back off and go back to where you were. Okay? Everyone got that? So it's the title property of the UI view controller, one down on the stack. And this stack is like a stack, computer science stack, right? You push and pop. Push things on, pop things off. So how do we push things on the stack? Well, we call push view controller. Okay? It also has the animated argument. And it's simple as that. You just send a message to the UI navigation controller saying, push this view controller on top of the stack of cards, and it'll then appear on screen. Okay? This is what was missing in that 2 slides ago. I needed to push something in that little space where something was missing here. I need to push my first view controller. So that's all that was missing. And we'll see that today. UI view controllers, conveniently, know what UI navigation controller they are in automatically. If they're being displayed in a UI navigation controller, they know, and it's the property called navigation controller. So the property navigation controller is a property on UI view controller, and if this UI view controller is currently in a stack, it will return the navigation controller whose stack it is in. All right? That makes it really easy to push something else on top of you. Because you're sitting there on screen, presumably, someone clicks a button that's going to cause something new to push on the stack, and you've got the UI navigation controller right there in a property. You just send it push to view controller, and on you go. Okay? The animated, by the way, is always yes, except for that very first push that we push before the UI navigation controller even comes on screen. We don't want to animate that. It makes no sense. But otherwise, we always animate it. And, it slides in or fades in. You don't really know, but that's part of the implementation of UI navigation controller, how it animates the appearing of a new card on the stack or the popping. So when does an MVC view controller come off the stack? All right. Well, mostly it comes off when the user hits back, right? Because they go back to the previous card. right? They push some things on, the user keeps hitting back, goes back. So you can imagine you're in iTunes and you're looking at your albums, and then you're looking at the songs on the albums, and then you're looking at the details about the song, the lyrics or something. It just keeps putting more cards on. And then when you're done looking at the lyrics, you hit back, you go to the song, back, you go back to the album, back, you go back to the list of artists, that's obvious. But you also can programmatically make the top card go off by calling pop view controller animated. So here's an example. Let's say we had a view controller with a view on it that shows some record in a database. Okay, some piece of information we pulled out of a database. And there's a button on there that says delete this record. And so the user deletes it. Well, as soon as you delete it, it doesn't make sense to be on screen anymore because I just deleted that record. So I want to pop myself off the stack. And so self navigation controller, pop view controller, yes. And that pops the top card. You can only pop the top one. There's actually a method to pop all the way back to just having one card, but it's pretty rare to use that. Okay? Everyone all right with that? Now, when you push cards on the stack, it's important how you pass data to them. We want to obey MVC here. Think of the thing you're pushing on as the view. Remember that the view doesn't really want to initiate conversation back except for through delegates. And that same thing is true here. When you push that card on, in fact, maybe even more strict, like you're not going to have target action between them. You might have delegates, but even there, you try to make it so that when you push a card on the front of the stack, it can live on its own. It can do all it needs to do on its own. It has its own MVC. Hopefully it's got all it needs to make it work. So you want to give it what it needs to make it work when you push it. Okay, so here's an example, some code. So here's an action, it's a target action message that's going to push another card on the stack. You can see that I've got this push E view controller, right, that I'm creating, and I'm setting some property in it to be some property of myself. In fact, I'm setting a couple of different properties to be properties of myself. And I'm also here setting the push E's delegate to me myself, but hopefully I wouldn't even have to do that. And then I push it. And then hopefully the push E can come on screen, be in the front of the stack, interact with the user, do all it needs to do, and then get popped off, and everything will be fine at the end. Okay? It's really nice to try and build self-contained MVCs that you can push on a stack, and they'll run by themselves, and they have all the information they need from the start to run by themselves. Instead of having to talk back to the previous cards on the stack and things like that, that starts getting messy. Just the more interfaces you have between things, the more difficult it is. And you're going to see our psychologist demo today. We're just going to load up the happiness view controller with the happiness and let it run. And it's just going to be all on its own. It's not going to be talking back to our psychologist card on the stack. Okay, so before I do this demo, let me talk about what's going to happen next time so I can get out of Keynote here. We're going to start talking about the iPad. The iPad has some user interface paradigms specific to it, like the split view and popover controller and things like that. And we're going to start talking about universal applications, building one application that will run on multiple platforms. Okay, to do that, it has to kind of have a little bit of conditional code in there, but there's a way to do it where it kind of all happens naturally. So we'll be talking about that. And we're also going to talk about input. We talked all about how views draw this week. Next week, we're going to talk about how do you get a pinch or a swipe or, a panning motion. How do you get your view to respond to that? All right, so that's going to be on tap for next week. All right, so the demo. What am I going to do in this demo? So first, we're going to take a quick look at happiness appdelegate.m. We actually looked at it on a previous slide, but we'll have it open, so we'll just take a quick look. And then I'm going to build this new application from scratch called Psychologist. And like I said, just ask a question, then gives you a diagnosis with the face. And we're going to create it using window-based application template instead of the view-based application template. And we're going to create a new UI view controller in code that will push the happiness view controller onto the stack of UI navigation controller. All right? And so things to watch for, like I say, window-based application versus view-based application template in Xcode. Notice how we're going to go into application did finish launching and create the initial structure of our app with the navigation controller. And then also notice how we are properly initializing and pushing this separate view controller, MVC combination, onto the stack. and then letting it just pop off by itself, and we never are involved again once we push it. All right? So that's it. That's what we're going to do. Again, you'll be surprised by how little code it takes to do all this. All right. First, I promised we would look at happiness app delegate. So here we are in our happiness application that we were doing at the beginning of class. So here's happiness app delegate, and you can see it's got a lot of wills and dids down here. Notice in dealloc, it's not really doing the right kind of release there. Don't pay no attention to the man behind the curtain. This, though, is the important thing. This did finish launching with options, right? And you can see that it's just adding our view controller sub-view to the window and making it visible. That's all it does. All right? So let's close that. Quit our task there. Quit that. And I'm going to make a new Xcode project. Okay? This one, though, I'm going to pick this thing right here. This is what we did before. This is what I'm doing now. Window-based application. Okay? It's not going to create a view controller for me. So I hit choose. I'm going to call this psychologist. I tend to mistype that often. And let's make some more space. Let's quit this. Make some more space here so we can see what we're doing. Make that smaller, that wider. Okay. So notice in classes right away you see the difference. No view controller, no psychologist view controller, right? And if we look at the app delegate, you can see that this application did finish launching method. Nothing. Just make key visible. It does have this main window.zib, so if I run this app right now, it'll have a blank window. Okay, but it's not much value to us. So how are we going to make this work? Well, the first thing I'm going to do actually, and you're going to do this in your homework as well, I'm going to go get the files for my happiness view controller and bring them into this project. And when you do that, there's a very important thing to watch. All right? So here I go. I'm going to developer. I'm going to my happiness. Here's my happiness. I'm looking for my classes. And I need all these, I need my controller and my face view and my zip file. So let's drag my controller in first. So I'm selecting both. And I'm just picking it up and dragging it in here. Now watch what's going to happen when I let this go. Okay? It says, do you want to copy this in? This switch, if you don't set this switch, you're going to be sad. Okay, because what it's going to do is create a reference to your other project, and if you ever delete that project or edit that code there, you're going to be using that version of it. So here you want to copy them out. Okay, make a copy of, in this case, my happiness view controller. So I'm going to click Add. So now here you can see that my happiness view controller code has been added to my project. I also need my face view. So let's get that. Drag that in here. Again, I always want copy. And then don't forget this, your zip file. Okay, so here's my happiness view controller.zib. Bring that in, put it in resources. Again, copy. Voila. Now, whenever I move other code into my application, I always like to build and run, just to make sure it compiles and everything. Of course, it's still blank because all I did was bring them in. I didn't put them on screen or anything like that. I just brought it in. So what do we do next? Next, we need to create a new controller. Okay, this is going to be my psychologist. This controller is the one that's going to ask me the question, how are you doing? That's different from the controller that's going to control the face. That's my happiness view controller. So how do I create a new controller? I go up here to File, New File, and just like we've created Objective-C classes before, we also have this thing, UI View Controller subclass. You see that? And really important, you want to click this box too. Because if you don't click this box, your UI View Controller is going to assume to implement load view for its view, which you don't want. You want it to be based on a zip file, right? So click that with the zip file. Click Next. I'm going to call this Psychologist View Controller. And so I have that. I'm going to actually move these up into my classes section right there. So now you see I have two controllers, Psychologist View Controller and Happiness View Controller, and I still have my custom view, and I have two zip files now. I have one Happiness View Controller. Let's look at that one. That's the one with the face view and the slider. And then I have another one, Psychologist, which is blank. All right? So let's go ahead and do the API of our Psychologist view controller, and then we'll wire it up in Interface Builder, and then we'll do the code to put it in Navigation Controller. Right? Those are the steps we're going to do. So this Psychologist view controller actually is going to have no instance variables and no properties. All it has is 3 IB actions. So one IB action is, I'm going to call it sad. And another IB action, I'm going to call it happy. And a third IB action, I'm going to call it so-so. Okay? So this is how I'm feeling. All right? And that's what our psychologist is going to ask us, but of course it's going to use psychologist speak to do that. So let's go ahead and open up our psychologist view. Here it is. All right? This is the zip file. Let's do hide others. Make some space here. And let's also close this. And close this so we don't get confused. All right, so here's our Psychologist view controller's view. So I'm just going to put a little text in here. I'm going to say, make it a little bigger. Let's say 24 point or something like that. And I'll say, how are you today? Oops. How are you today? And we're going to have some responses here, which are going to be buttons. I'm going to say, my dog ate my homework. And then, actually, let's wire this up real quick. It's my dog ate my homework. That looks like a sad one. Then I'll have another button. I'm going to call this one wonderful. Oops. Probably don't want a question mark. That your psychologist really be upset by that one. Actually, they'd probably earn their pay then. They do that one. So wonderful, though, we're going to say is happy. And then we're going to have, what's it to you? Okay. Probably that's sad from the, but we're going to say that one is so-so. Okay, so that's it for our psychologist user interface. Our psychologist is going to ask us this question, how are we doing? We're going to answer with one of these 3 answers. And let's go ahead and implement this psychologist. I'm going to copy and paste because it's less typing. You can see you got all this help. We don't have any instance variables, so we don't need any view did unload or dealloc. We just have our 3 things here. So I'm going to implement these by saying self show diagnosis, and sad would be a 0 because I'm going to use the happiness to show my diagnosis. And then this one would be self show diagnosis, and happy would be 100. And then this self show diagnosis 50. All right, so that's obvious. So the question is, how do we implement show diagnosis? And that's the magic of pushing controllers. So let's do that. So void show diagnosis int diagnosis. All right. So all we need to do here is create a happiness view controller, set its happiness, and push it. And then we're done. So we're so done at that point, we're going to release our happiness view controller. All right? Because we'll already have pushed it on the navigation stack of the UI navigation controller. We're not going to send it any more messages. We're done with it. And when it pops off the stack, it'll get deallocated. And that's why I'm saying, up till now, you've never seen a controller get deallocated. So who cares about dealloc? But now you're going to see that it's common for view controllers to come on screen, come off screen, and just deallocate it. Okay? So let's do it. Happiness view controller star, I'm going to call it HVC equals happiness view controller alloc init. Now I'm calling with init, so I'm going to get that behavior where it's going to call init with nib name bundle with both nil, and so it's going to look for a zip file called happiness view controller.zip, and it's going to find it because I remembered to bring it in. If you forget to copy that over, it's not going to find it. It's not going to work too well. I got to import my controller. All right, so I've got my controller. Now I just need to set its happiness to our diagnosis. Right? It's got all the information it needs to go now. Let's just, self navigation controller. Remember that all view controllers, including the psychologist, have a property which is the navigation controller they're in push view controller, HVC, animated, yes, because we're presumably already on screen here. And then, and this is important to understand, HVC release. Okay? Because I alloc init that HVC. I own it. I'm done with it now because I pushed it onto the stack. I don't need it anymore. I'm releasing it. Some people get a little upset by this, like, oh, but you just released something and it's on screen. Yeah, it's on screen, but the navigation controller has it now. It owns it. Okay, it's just like putting something in an array. The array owns it. You can release it then. Okay? So that's it. That's all we need to do to make our psychologist do the right thing. But we still have to build our user interface. If we ran this right now, it would still just be a blank white screen because we haven't put any we never created any navigation controllers. We haven't put anything on screen. So let's do that. And we do that in our application div finish launching. So here I am in psychologist appdelegate.m, right? And I'm just going to create a UI navigation controller. Call it navcon. UI navigation controller, alloc init. All right, that's all you need to do to create one. It doesn't have a zip file associated with it. You just alloc init it. I think init is its designated initializer. And then I'm just going to push, well, let's be a little more clear here. I'm going to create a psychologist view controller. We'll call that PVC equals psychologist, view controller, alloc init. Okay, now we better import psychologist view controller. And then let's go ahead and navcon push. All right, we'll push the PVC. And here we don't want the animated, right, because this is not on screen yet, so it'd be a waste of resources to try and animate it, so we'll say no. And we're done with PVC, so we can go PVC release. And then we can just say window, add subview, what? Okay, navcon.view. So that's our navigation controller's view. Make sense? And everyone see again why we can release the PVC there? Because we've already pushed it, so we don't need it anymore. Now, one thing is navcon. You might say, hey, I allocated a init navcon. When am I releasing that? Not good. And that's true. Probably what I should do here is create an instance variable in my app delegate, which is to hold the navigation controller. And then down in my dealloc down here, I should release it. Now, you will not see people doing that very often. And the reason for that is this is the root navigation controller, and it only will go away when the whole app quits. So deallocating, it's trying to recover its allocation. In other words, this application delegate is never going to get freed in a way that we got to clean up this navigation controller. Okay. Now, if we were putting this navigation controller in a split view, then the navigation controller, we would just release it as soon as we put it in the split view, right? But the split view then probably wouldn't get released. But that's okay, right? Because it's going to live the entire time of the app anyway. So let's see, let's debug any problems we have, if any. Looks good so far. How are you today? So let's try the dog ate my homework. Oh, that's sad. Or wonderful, woo. Or what's it to you? Now this thing still works, right? The thing we pushed on, because this is the happiness view controller running in its own world, totally independent from the psychologist. When I click back, it got dealloced because it got released by the UI view controller. It's off the stack and no one's pointing to it. It got dealloced, okay? And the zip file, everything got thrown away. And then when I click this again, it's getting reconstituted from the zip file. And that might seem like, why, you're kidding me. But it's really not a lot of memory usage here, and it's pretty quick to allocate these objects, and it keeps your memory footprint small. And remember that on a device like the iPhone, you know, memory is at a premium. This is not a big, 10 gigabyte memory machine. It's a little small machine that's trying to be efficient with its power usage and things like that. So hopefully that makes sense to everyone. Now, one last thing I'm going to do is notice there's no title up here. You see this? No title. That's no good. And no title here either. So how would we set the title on the top here? Remember that it gets the title from whatever view controller is currently being displayed. So, for example, in our view controller for the psychologist, let's have this HVC. Oops. Let's set the HVC title to be NS string with format %GD the happiness. Okay, or we could actually put that in the happiness view controller as well. Diagnosis, actually. Okay, so now it's going to set the title, and we're okay with on-memory management here because that's an auto-released object, the string with format. So now if we do that, it's actually going to show us the numeric value, but it's showing us the diagnosis value. So it's 100. If I change this, it's not changing because that's not displaying the current happiness. It's displaying what the diagnosis was at the time. All right? And the psychologist also might set its own title to psychologist or whatever, the name of the psychologist or whatever, and we're running out of time, but that you could do in its init, or I'm going to show you really quickly here because you might want this for your homework. There you go. So psychology on there. So everyone got that? Make sense? So I'm going to post this code for psychologists and for the second half of happiness probably tomorrow morning. Unfortunately, I have to get out of here right now, and it takes me a little zipping up and stuff to do it. But hopefully that gets it. One thing I want to show real quick, everybody loves this part, is I want to show you kind of what your homework is going to look like when it's done or partway through. Okay, so I know that on the last homework on Piazza, there were some people saying, well, tell me, how do I know what it's supposed to look like? What are the inputs and outputs? So, I didn't go and put a whole bunch of screenshots in your homework saying this is what it should look like. But here, I'm just going to run it to give you an idea. This is not what your final homework might look like, but in process, because I haven't done the last homework part of the assignment, which is make it all look really good, because that does matter for this one. But it does work here. So I'm going to try, for example, let's graph X cosine. So I'm just typing X cosine and graph, and you can see that it makes a graph of it, and I can zoom in and zoom out. All right. So your assignment is just to create this navigation controller, put your old MVC in one of it, create a new view controller that draws this graph of whatever your expression is, and has the zoom in and zoom out. All right. That's basically your homework. Don't worry about too many things like, let's see, what if we do this? This is a discontinuous function. Notice these lines coming down. That's totally wrong. But in the homework, I tell you, it's okay if you want to do line twos from point to point, even though that's not quite right because it might be discontinuous, or you might be so zoomed out that it's drawing a line two when really it should be dots or whatever. But don't worry about that. The main point here is just to learn how to do these two view controllers, push one on top of the other, and how to do a custom view. By the way, on the custom view, I will give you the code that draws these axes, right? So you won't have to do that. Okay, that's it. Thank you very much. Good luck on your homework. It's already posted, and we'll see you next week.
For more, please visit us at stanford.edu.